Hi, my name is Isaac Chu, student ID 24005568. I am from Engineering Mathematics 1 under the lecture of Dr. Dennis. So right now I'm going to explain briefly about Stokes' theorem. Stokes' theorem tells us that the circulation of a vector field around a closed curve C is equal to the flux of the curl of that vector field through a surface S bounded by that curve. It helps us convert a difficult line integral into an easier surface integral, or the other way around. So for example, if the boundary is a circle, instead of doing a long line integral of around the circle, we can use Stokes' theorem and integrate over the flat disk. That makes the calculation simpler. So for example 1, we have f equals to minus y, x, and z, where we have z equals 4 minus x squared minus y squared, and z is also equal to 0. So step 1, calculate curl f. We do the curl of the function here. We got 0, 0, 2. Next step, find surface normal. We nabla the function of z minus fxy, where z is equals 4 minus x squared minus y squared, and then we will get this 2x 2y 1. That is the end. Okay, the next step we need to dot the product of both these calculation. So you get 0, 0, 2 dot the 2x 2y and 1. We get 2 here. Step 4, find the boundary. We equals to the z in this equation, we equals to 0. We got the x squared plus y squared equals to 4, where we know that x squared plus y squared equals to r squared, where r squared equals to 4, r equals to 2. That's the radius. So we know that this is a circle, so the r is between 0 and 2, and the theta is between 0 and 2 pi. Next, and the final step, we just solve. We integrate we put in the boundaries and just integrate it, do the simple integration, and we got 8 pi.
Hello, my name is Muhammad Abdul Rahman, student ID 240065553. So I'm gonna explain to you about the second question today. So the question is we got f x y z equals to negative y I plus x j plus 0k. We also got x squared plus y squared equals to 4, z equals to 0, and radius is 2. So the first step is we compute the curl. So the vector field is negative y, x, and 0. And then we compute the curl, and then for the I component we got 0, the j component we got 0, and the k component we got 2. So this is the curl, which is 2k. So the next step is we apply Stokes theorem, which is integral f dot dr equal to integral curl dot n ds, and then we take the dot product, and then we calculate. We got 2k dot k, and then we got 2 for the dot product. And then the last step, which is the third step, we integrate over this. So integral of 2 ds equals to 2 dot area of this. So the area of this radius 2, which is area pi 2 squared, which is 4 pi. And then the last one, we we integrate 2, which is this one, 2 multiplied by 4 pi, which is the final answer is 8 pi. So that's all for this question.
Hi everyone, I am Tarun, student ID 22010950, and today I will be explaining the Stoked theorem real world application of this presentation. So, why do we need Stoked theorem? Because Stoked theorem is a really important part of electromagnetism. Stoked theorem is also applied in Faraday's law of induction. So now in physics, we will look at how Maxwell's equation states this, where E is the electric field, D is the magnetic field. So this says that a changing magnetic field creates a curling electric field on the left side. So let's apply Stokes' theorem and integrate both of it over a surface S, which is the area inside a loop of wire C. Alright, so now we have applied Stokes' theorem onto it, and look, the left side is actually exactly Stokes' theorem. So we can replace it with the line integral, which is over here. So once replacing it with a line integral, this is what we get. So now I'm just going to explain exactly what are we looking at. Okay, so on the left side is the total push, the voltage or EMF on the electrons inside the wire loop. And on the right side, it's the magnetic flux. So basically, this equation from this translates into voltage equals the negative change in magnetic flux over time. Alright, so this equation is actually used in many parts of our life. Even in our daily life, all the electricity we get has something to do with this equation, because hydroelectric power plants use this concept to generate electricity. Okay, so they use steam, water, wind, anything to spin a magnet inside a coil of a wire. Right, this changes the magnetic flux, which Stokes' theorem proves that will create the voltage inside the wire. Alright, and for conclusion, so basically Stokes' theorem connects the flow around a boundary to the spin on the surface of the integral. Stokes' theorem can be used to pick the easier path. So if let's say a 3D line integral is hard, we can try the surface integral. If the surface integral of the curl is hard, then we can also choose the boundary line integral. All of this can be done just by using Stokes' theorem. Besides that, you can use any surface that shares the same boundary. So for example, if you have a paraboloid, you can pick the circle surface at the bottom because it shares a boundary with the curve. Alright, and always use the right hand rule in the direction of your boundary C with your surface normal N. So why Stokes' theorem matters is because it's the heart of all electric generators, thanks to Faraday's law. I hope this helped clear things up, and it is a powerful concept. Once you see it as a shortcut, you'll understand why Stokes' theorem is so important in our daily lives. Thank you.